Gruesome murders, museum heists, and scams that could threaten the health of millions. True crime is everywhere, but scientists know how to fight it. So to start off this SciShow compilation, here's Michael to tell you what forensics can actually solve and how it's different from what you see on TV.
Let's talk about crime shows. In a non-stop media stream filled with reality shows, cooking competitions, and whatever's happening in Westeros, police procedurals are probably as close as most of us are going to get to seeing science portrayed in primetime. And the techniques that crime fighters use to catch bad guys vary from show to show, but a lot of the time it involves forensics, which is basically the use of science in the field of law, in this case, criminal law. Different kinds of forensic investigators have different roles, like analyzing crime scenes or running tests in the lab. And they can specialize beyond that, focusing on analyzing DNA or bullets, for example. Generally, they all have an undergraduate degree in a scientific field, like chemistry or biology, or a more targeted degree in forensic science itself. Some have a graduate degree too, and medical examiners, or MEs, usually have a degree in medicine. But they all have one thing in common: using science to find, gather, and analyze evidence that can be used in court. However, Hollywood seems to think that real science doesn't always make for entertaining TV, so writers tend to take some liberties with how forensics really works. Most of the time they aren't completely off the mark. For example, the tests they use on the show might actually exist, but they wouldn't be nearly as fast or accurate in real life. And the technology they use is just ridiculous. We're here to clear that up and talk about what forensics can actually do, which turns out to be pretty interesting all by itself. And to do that, we're going to solve a hypothetical crime. So here's our case. Someone finds a dead guy in an alley in Chicago. The cops secure the scene and the forensic investigators show up around 11 p.m. to gather clues. When they go through the victim's pockets, they find a receipt for a bottle of soda from a nearby convenience store time-stamped at 5 p.m., 6 hours earlier. And, according to the ID in his wallet, his name is Bob. The medical examiners want to know how long Bob has been dead, which could be key to finding and catching his killer. So there are a few things they can check, and they all happen to end in the word mortis, which makes sense because that just means death in Latin. First, there's livor mortis, or how the blood pools. Now that Bob's heart isn't distributing his blood anymore, it just goes where gravity takes it, and that makes the skin look purplish from the outside. But if a body's been dead for more than 12 hours, the blood will have coagulated or dried. It stays in place, and if you shift the body, the blood won't pool in a new spot. Now, Bob's blood seems to still be very liquid, so he's been dead less than 12 hours, though of course the examiners already knew that since he was alive and well in the convenience store only 6 hours ago. Next, they check if rigor mortis, the stiffening of the muscles after death, has set in. And rigor mortis is proof that your muscles work in kind of the opposite way than you might expect. Since running and lifting weights and doing things that require your muscles is hard, you might think making your muscles contract requires a lot of energy. But that's not true. Your body actually uses energy to make your muscles relax, not contract. So after someone dies and their muscles stop getting chemical energy, their muscles can't uncontract, so their bodies stiffen. This effect starts about 2 hours after death and lasts until about 36 hours in, when the muscles decompose enough that they can't hold their position anymore. In Bob's case, rigor mortis does seem to have set in. He's frozen in place, so the body's probably more than 2 hours old. They'd like to get a more accurate number though. If the body is close to 6 hours old, that means he was probably murdered right after he left the store. So they take the body's temperature. Rectally, a detail they don't normally show in crime dramas, and it's 29 degrees Celsius. Now, normally, a body loses heat at a rate of about 1.5 degrees Celsius per hour, a process known as algor mortis. When Bob was alive, his body temperature would have been 37 degrees, so it's lost 8 degrees so far. You'd think Bob's been dead for very close to 6 hours. And in a TV show, the ME would probably say that. But there's a problem. This is a cold winter evening in Chicago, and it's about 5 degrees outside. The body's going to lose heat a lot faster to the colder air, but it's hard to tell exactly how fast. Given all the information they've gathered, our MEs put the time of death between 5 p.m. and 7 p.m. There's no way to tell if Bob was murdered right after he left the store or 2 hours later. So, detectives head to the store and ask to review the security camera footage, hoping they'll be able to figure out if anyone was with Bob when he bought his drink. Turns out that as Bob left the store, the camera picked up someone quickly emerging behind a nearby tree to follow him down the street. But it was so far away that the stalker's face is all pixelated and blurry. You can hardly even tell it's a face, let alone whose it is. Now, if this were a TV show, usually the detectives would zoom in on the face and enhance the image, somehow, and then run the magically clear photo through a facial recognition database. And then maybe the next part of the story is that they get a match, which leads them to another clue. But in real life, there's no way they could enhance a picture like that. When a camera captures a digital image, image, it's recorded as data that forms a map of the colors in each point or pixel in the picture. And those pixels cover bigger or smaller amounts of space depending on the resolution or how many pixels there are in that image. The color of each pixel is recorded as the average of all the colors within that space. But once the color is stored as the average, that's it. You can't enhance the resolution of a photo because there's no way to tell which amounts of which colors went into that average in each pixel. Like, let's say your camera has 8 megapixels, which is pretty typical for a smartphone. That means it takes a picture with 8 million pixels in it. That sounds like a lot, but let's just say you want to take a picture of something really small or really far away, like a person at the other end of a field. You can zoom in a lot, but you still probably won't be able to make out much detail. Whatever's written on their t-shirt, for example, might just look like a few blocky dark green squares. And there's no way you can enhance those squares to see that the dark green pixels are just averaging together the bright green letters on a black background that spell out SciShow, which of course are available at dftba.com/SciShow. If you wanted to be able to make out what's on the shirt, you need a lot more pixels that would each depict a smaller area of that mysterious figure. But let's say our real-life detectives look through some more of the footage and realize the person who was following our victim was actually back in the store about 3 hours later. They can tell because he was wearing the same clothes. The camera captures him as he puts something down on a shelf, then leaves. They get a close-up picture of his face and run it through the database. Facial recognition actually has a long history because it's one of those things that humans tend to be very good at, but it's hard to get computers to do well. Humans are excellent at finding patterns, but the computers have to be taught what to look for. Human features, it turns out, are arranged in very specific ways, but the specifics are unique to each person. For example, everyone has a certain curvature to their eye sockets or distance between their nose and mouth. Those dimensions are different for everyone, but computers can be programmed to measure them and then use the data to identify faces. Together, these metrics make up a face print, and there are actually databases of face prints compiled from things like mugshots. A computer can take an image of a face, like the one of the man following Bob, and compare his face print to ones already in the database. On TV shows, that database will usually be shown as a sophisticated system with all the data in one place. All the detectives have to do is type some commands on a keyboard and the computer starts cross-referencing with every picture ever taken in the country. But that kind of law enforcement database doesn't really exist, at least not yet. The FBI is working on what they say will be the world's biggest database of biometrics with tens of millions of records. But for now, if cities have searchable faceprint databases at all, they're usually local. Chicago, for example, has one called NeoFace that looks for matches in the police photo database. In our case, the investigators catch a lucky break. When they run the suspect's face print against the Chicago Police Department's database of mugshots, they find a match. His name is Charlie, and he owns a hardware store a few blocks away. When the investigators inspect the shelf that they saw him putting something on, they find a wrench with a dark red stain. Thinking that it might be their murder weapon, they take a swab of whatever's on the wrench, then do something called a Kastle-Meyer test to see if it's blood. On TV, you might just see them spraying some liquid onto the swab to see if it changes color, but in real life, they'll need to use 2 different substances. First, they add the chemical phenolphthalein to the swab, then a couple of drops of hydrogen peroxide. If there's blood in the sample, the 2 compounds will react with each other, turning the phenolphthalein a vivid shade of pink. Blood contains hemoglobin, which acts as a catalyst, basically the substance that makes a reaction happen. With hemoglobin's help, the peroxide reacts with the hydrogen in phenolphthalein and becomes water. The new hydrogenless form of phenolphthalein then turns pink. If there were no blood on the wrench, the reaction wouldn't happen because it wouldn't have a catalyst to help it along. But in this case, the swab from the wrench does turn pink, meaning that the stain is probably blood, so the investigators take the wrench for further testing. Back at the lab, they run a DNA analysis on the blood from the wrench and compare it with Bob's. If it's a match, they've probably found the murder weapon and their murderer. Now this test actually works pretty much like it does on TV. DNA is the molecule that makes you who you are. Long strings of 4 different compounds or base pairs in a particular order. And everybody has their own unique set, except for identical twins. So, if you have a DNA sample, that's a really good way to identify someone. But forensic teams don't just sequence everyone's DNA. Instead, they usually use a technique known as STR analysis to match DNA samples. It's based on the idea that everyone's DNA has certain sections with repeating patterns of base pairs, but the number of times the pattern repeats itself varies from person to person. The STR looks at 13 of those repeating sections, and the odds of 2 people having the exact same base pairs in all 13 are about 1 in a billion. Meaning, there are probably only about 6 other people in the entire world who have the same STR profile as you, and forensic experts figure that's accurate enough. Plus, it takes less than an hour and a half to run. So, in our case, investigators find that the blood on the wrench did come from Bob, which certainly makes Charlie a suspect, but there are still open questions. Was Bob's encounter with the wrench what killed him? Was someone else involved besides Charlie? Unfortunately, I can't answer those questions for you because we're out of time and Game of Thrones is about to come on.
Wait, so I need to know if Charlie had an accomplice. I can't stand a loose end like that, which is why I'm not in forensics. In that line of work, a lot of mysteries remain unsolved. But every now and then, a cold case can be closed thanks to science. Here's Stefan with 5 of those cases.
The history books are full of fascinating mysteries. Many of these are lost to the passage of time. The historical record is never perfect, and some details can never be recovered. But new technology can also unlock new clues. The better our techniques get, the more information we can wring from the historical and physical evidence to unlock long-dormant secrets. So here are 5 fascinating historical cold cases that once seemed unsolvable, but have been cracked, or at least cracked open, by some modern science. In 1959, a group of 9 hikers died under strange circumstances in the Ural Mountains, and the condition in which they were found was kind of disturbing. They cut themselves out of their tent and fled into the minus 25-degree night, wearing only their underwear and socks, some even barefoot. The bodies were over a kilometer downhill from where they had cut into the snow and pitched their tent, and somehow they had sustained bizarre injuries, including impact to their chests, cracked skulls, and a missing tongue or eyes. Traces of radioactivity were even found on their clothes. This is known as the Dyatlov Pass incident, and many ideas have been proposed to explain it, from nuclear weapons to aliens to Yetis, but it remained officially unsolved for decades. In 2019 and 2020, a Russian government investigation concluded that an avalanche was the most likely explanation, but gave few details about how it occurred, which means not everyone was totally convinced. You see, scientists had previously dismissed the avalanche theory. There wasn't much avalanche debris, and the injuries weren't consistent with avalanche victims. And the group was camped on a slope less than 30 degrees. Such an incline is often considered too flat for an avalanche, and whatever happened in the middle of the night. An avalanche would be more likely to happen as soon as the hikers had cut into the snow. If this was an avalanche, it would be a pretty weird one. It wasn't until 2021 that scientists published a plausible scenario for an avalanche, thanks to the movie Frozen. Using the same method Disney used to simulate snow in the movie, researchers recreated the conditions on the mountain that night to see what would happen. First of all, they found that a combination of a buried layer of weak snow and strong winds blowing snow down the mountain could trigger an avalanche, even on a gentle slope. Second, they also found that slow accumulation of snow due to the winds could trigger the avalanche many hours after the hikers cut into the snow to make their camp, a delayed reaction. Finally, they calculated that when the slab of snow slammed into the tents, it wouldn't have had enough force to kill the hikers inside, but it would have crushed the hikers against the compacted snow and skis underneath the tent. It's rare for avalanches to trap people against hard objects like skis, which could explain the uncommon injuries. What exactly happened next? Well, we can't really be sure what decisions the hikers made and why. They likely fled into the night unable to dress properly in the chaos. As for the radiation, at the time hikers often carried lamps with the radioactive element thorium in them, so a broken lantern could have explained that. It doesn't explain what happened after the hikers fled their tent, but it's clear that an avalanche, even a bizarre one, is a plausible first step. And simulating strange events like this could be an essential step to figuring out how to be safer in dangerous alpine terrain and avoid tragedies in the future. Now, in May 1821, the famous French Emperor Napoleon Bonaparte died while in exile on the remote island of St. Helena in the middle of the Atlantic. Newspapers reported that an autopsy concluded the cause of death was stomach cancer, but that didn't stop speculation that foul play was involved. The conspiracy goes something like this. Napoleon had escaped an island exile once before to take over France, so what was stopping him from doing it again? Maybe a group of powerful shadowy figures had conspired to poison him with arsenic and stop him for good. And some evidence seemed to support this idea. An analysis of Napoleon's hair in 1961 found elevated levels of arsenic. But arsenic was pretty common in some everyday items at the time. It could have even come from the wallpaper at his house on St. Helena, and a 2004 paper found arsenic in his hair from before then. So in 2008, a study took a careful look through that original autopsy and the medical records leading up to his death. The researchers reanalyzed these in the context of modern medical knowledge and compared them with those of stomach cancer patients. They found no evidence that Napoleon had the symptoms of gradual arsenic poisoning, but he did have symptoms consistent with an infection of the bacterium H. pylori. This is significant because we know the inflammation from this infection increases someone's risk of stomach cancer. In fact, it's responsible for 95% of stomach cancer cases. As Napoleon's symptoms worsened, they followed the expected course for an infection leading to stomach cancer and the growth of a large 10-centimeter tumor. So it seems the conclusion is clear. The initial diagnosis was indeed correct. He may have even had a family history of stomach cancer. Records aren't definitive, but it appears his father may have died of something similar. The Romanov family were the last Russian monarchs. They were executed in 1918 after the Bolshevik Revolution began a year earlier. This was an attempt to discourage their remaining loyal supporters supporters and to prevent any hope of rescue. The entire family was killed by firing squad and buried nearby. This included Tsar Nicholas, his wife Tsarina Alexandra, their 5 children, and 4 members of their staff, 11 people in total. But ever since then, rumors have swirled that 1 or 2 of the children just might have escaped alive. In fact, over 200 people have come forward claiming to be those long-lost royal children. And clearly, they can't all be right. The mass grave was discovered in the 70s, but kept a secret until 1991 when the Soviet Union fell and the remains could be exhumed. But in many ways, this only added to the rumors. The grave contained only 9 bodies. Notably, 2 of the children were missing. The Crown Prince Alexei was unaccounted for, as was one of his sisters, likely one of the 2 younger ones, either Princess Maria or Princess Anastasia. DNA couldn't narrow down which sister was missing, and experts from Russia and the United States fell into 2 different camps. A Russian team attempted to reconstruct facial features using the skulls and concluded that Maria was missing. But an American team focused on figuring out the ages of the remains from physical features on the skeletons and concluded that the missing princess was the youngest, Anastasia. But a breakthrough came in 2007 when amateur archaeologists found a second grave nearby with the remains of 2 children in it, 1 boy and 1 girl. DNA analysis confirmed the boy was the Crown Prince Alexei and the girl was one of his sisters. We still can't definitively say which sister is which, but we now know that all family members are accounted for, and sadly, they all perished in 1918. Now, this next one isn't wrapped up with a shiny bow yet, but thanks to science and some recent discoveries, it's getting closer. Sir John Franklin and his crew of 128 sailed to the Canadian Arctic in 1845 aboard 2 ships. Their goal was to search for a northwest passage, or a shortcut from Europe to Asia. But their ships ended up caught in the ice for 19 months, until the crew abandoned them in an attempt to make their way south and find help. But none survived. So why didn't they make it back? 105 of them made it to the point of abandoning ship. Many have proposed that lead poisoning is what doomed the expedition. Their food was stored in cans sealed with lead solder. A 2018 study analyzed bones and teeth from crew members to figure out if this was indeed to blame. And while the researchers did find high levels of lead compared to modern standards, or to the contemporary Inuit living nearby, they don't think it's what ultimately did the sailors in. They found crew members who died early in the expedition had similar lead levels to those who died later. This suggests that the high levels may have resulted just from a lifetime of exposure, not just the time spent on the expedition. So to confirm this, they tested the remains of British Navy sailors who lived at a similar time but were not on the expedition, and they found similar lead levels. So it's likely this expedition didn't face any unique risk from lead. Just being a sailor at the time exposed you to a lot in the first place. So what did end up killing them? Probably various factors. The Arctic is a tough place to live if you don't know how to survive there. One other mystery was what happened to the 2 ships that they abandoned, since they didn't remain stuck in the ice forever. After over 150 years of searching, the first was found on the seafloor in 2014, and the second 2 years later. As scientists explore these wrecks, what they find should help us further understand what happened on this tragic expedition. Marie Antoinette was the last queen of France who famously met her end during the French Revolution. She was married to Louis XVI, but there are long-standing rumors of a possible affair with a Swedish count, Axel von Fersen. The 2 wrote letters back and forth from 1791 to 1792, but the surviving copies have sections of text redacted. Someone has scribbled over them, leaving historians to speculate about what they say and who censored them. But a study published in 2021 successfully used some clever science to see through the ink and reveal what's underneath. The researchers used X-ray fluorescence. This works by hitting an atom with X-rays, causing a low-energy electron to be ejected from the atom. When another electron drops down to fill the gap, it releases X-rays unique to that particular atom. By detecting this energy, the machine can determine what element that atom is. In this case, the atoms in question make up the ink on the page of the letter. So by scanning the ink, the researchers can make a map of each element on the page. The ink used to black out the letters had a slightly different composition than the ink used to write them. So by mapping the copper, iron, and zinc in the ink, they were able to reveal the words underneath. Of course, the real question is, what did they say? Well, the team is still working on that. The text is pretty distorted, and the scientists are working with historians to be sure that they get it right. But they did reveal that the redacted sections tended to be the more sentimental ones, and the language used, words like beloved, tender, dear friend, adore, and madly tend to imply a very close relationship between the queen and the count. The study also figured out who censored the letters, and it turns out it was Count Axel von Fersen himself. From handwriting analysis, they knew he made a copy of each letter he received. The ink analysis revealed that the redacting ink was always similar to, but not quite the same as the ink used to recopy them, which suggests it came from the same source shortly after. Ink composition can change slightly even from the start to the end of a letter as the liquid level goes down in the inkwell. The ink used to redact the letters was different enough in composition that this method could see through it, but similar enough that it's clear it came from the same source. We're not entirely sure why the Count copied and then redacted the letters he received, but it's likely he could have been trying to protect Marie Antoinette or himself. And it goes to show how future technology can undo security measures that were probably pretty effective at the time. Though the composition of the ink does change after a while, and on some of the letters, the original writing is too similar to the redactions to make out. So if you don't want your letters read by gossipy scientists in a couple hundred years, maybe just burn them instead. And there you have it. 5 cases that have been cold for decades, even centuries. All it took was some modern analysis to reveal critical clues that cracked them open, or at least to help make some good progress. But these only scratch the surface. The history books are still full of unsolved cases, just waiting for a resourceful scientist to come along and crack.
From Napoleon to Marie Antoinette, there have been a lot of mysteries surrounding famous deaths. But as we learned from Bob's murder, sometimes people you've never heard about become the stars of even more intriguing stories. That's true for anatomist Johann Viersung. Here's his story. On August 22nd, 1643, the anatomist Johann Viersung was talking with a few of his neighbors outside his home in Padua, Italy, when suddenly, bang! The professional corpse dissector was murdered, bleeding out from a gunshot wound. But who killed him, and why? Poor old Viersung certainly had enemies, professional rivals of sorts. They all studied an unassuming organ in the human body, the pancreas. Today, the pancreas might be best known for a hormone it produces, insulin, or the disease you get when it doesn't produce enough insulin, diabetes. Viersung didn't know anything about that, nor did anyone else, but he had a hunch it did more than what most people thought at the time. That may have been the thing that got him killed. And the weird thing is, that was just the beginning of the violence inspired by the pancreas. The pancreas is about the size of your hand and sits behind your stomach. The ancient Greeks knew it was there, but had no idea what it did. The works of Aristotle, Herophilus, and Rufus of Ephesus, all ancient Greek physicians working between 400 BCE and 100 CE, make brief mention of the organ, but apparently they didn't think much of it. The name itself simply means all flesh. Not long after, the famous Greek and Roman physician Galen proposed an actual purpose for this blob of flesh. He said maybe it's there to fill the space between the other organs and protect the veins and nerves. In other words, a bit of bubble wrap that pads and props up all the important stuff while you walk around. Which was definitely wrong, but the idea stuck around for more than a millennium. Eventually, the Renaissance arrived. In the 1500s, physician Andreas Vesalius published detailed diagrams of the pancreas. He said it looked like a big gland, and glands are defined by secreting stuff, like sweat glands, for example. But ultimately, he agreed with Galen that it was probably just there for support. Meanwhile, Gabriel Fallopius of fallopian tube fame disagreed, because four-legged animals also have pancreases, and based on where the pancreas sits behind the stomach, it is doing nothing to support any of their organs. But despite pointing this out, Galen's idea persisted. Now, Vesalius, Fallopius, and many other Renaissance-era physicians worked in Padua. For centuries, the Italian city was known for its friendliness to cutting-edge research, including the dissection of cadavers. And I'm talking public dissections, completed not just in lecture halls, but modular, portable theaters that you could set up in courtyards or even in professors' homes. These dissections were so popular, permanent theaters were built so everyone could get a good view. Padua has the world's first permanent anatomical theater, completed in 1595. It's still there, and they offer tours. So it's no wonder that aspiring physicians from across Europe traveled to Padua to make a name for themselves. cells, including Johann Wirsung. In March of 1642, a year before the assassination, Wirsung and 2 students dissected a pancreas from an executed criminal. But instead of reaffirming this was just a lump of all flesh, Wirsung found a duct that led toward the intestines. This big gland-shaped thing actually had a path to secrete stuff into another organ. To stake his claim for this discovery, he had sketches of the organ and its duct engraved and sent to other leading physicians. You could even call them unsolicited duct pics. But Wirsung never had the chance to present his work publicly. That fateful August evening, 3 assassins stalked him through the streets of Padua and shot him outside his home. A neighbor saw it all go down, and Wirsung shouted one name as he bled out: Cambier! That's Belgian doctor Jacobus Cambier, his relative Nicaise Cambier, and an unknown medical student. According to one Wirsung biography, Dr. Cambier shot Wirsung, quote, for personal reasons of hatred. Or I guess the Italian quote of for personal reasons of hatred. But the conspiracy might go even further. Remember how Wirsung wasn't alone when he dissected that criminal's pancreas? One of the students with him, Maurice Hoffman, claimed that he'd shown Wirsung an equivalent duct inside a rooster pancreas ahead of time. Recipients of Wirsung's duct images wanted to call it Wirsung's duct. Hoffman wanted to name it for himself. So maybe Hoffman paid the Cambiers to kill Wirsung out of professional jealousy. The world may never know exactly why Wirsung was assassinated, but there was still a lot to learn about the pancreas for anyone willing to take the risk. Fast forward to the 1800s, when people started applying the scientific method to medicine. Prior to that point in history, physicians were focused on structure and anatomy, which explains all the dissections. But in the 1800s, researchers finally started running experiments to understand how the body works, creating the field of physiology. And in France, big-deal physiologist Claude Bernard showed that the stomach is not the end-all be-all of digestion. His experiments in the 1850s showed that pancreatic secretions are key for digesting both fats and starches. A few years later, this time in Germany, Paul Langerhans put the pancreas under a microscope to find out where all these secretions were coming from. He saw the duct of Wirsung and clustered around that duct some berry-shaped cells producing digestive juices. He also saw another type of cell, each isolated from one another, which together resembled a bunch of little islands. Today we call the berry-like cells acinar cells, from the Latin for berry, and the island-like cells islets of Langerhans. Presumably, no one tried to kill him over a disputed discovery. Don't worry, there's still more violence to come. In the 1890s, researchers began to connect the pancreas, specifically the islet cells, with diabetes. Today, over 800 million people have diabetes around the world, including over 38 million people in the United States. About 9 million people worldwide and just under 2 million in the US have type 1 diabetes, which is what we're going to focus on. Scientists don't know exactly what causes type 1 diabetes or how to prevent it, but it tends to start in childhood, and if you have access to and can afford healthcare, it's a manageable chronic disease. If you were born before the 1920s, though, your outlook was a lot more dire. The key problem with diabetes is how the body uses sugar. People with the disease can experience very high blood sugar, high blood acids from breaking down fats for energy, or very low blood sugar. All of these can put that person into a coma. The only treatment available to prevent these crises was an extremely restrictive diet with low calories and low carbs. So when someone was diagnosed with diabetes, they lived for less than a decade on average. There had to be a better way. And thanks to that early pancreas research, doctors of the early 20th century knew where to start looking. Research teams around the world were asking questions like, how does the pancreas usually work so people don't have diabetes? What do the islet cells produce that's different from the digestive juices we already know about? And can we purify that useful thing and treat diabetes with it? The First World War threw a massive wrench into some of that research. Some projects in Germany and the US never recovered despite some initial promising results. But the most successful story comes to us courtesy of Canada. In 1920, Dr. Fred Bonting left his struggling surgery practice and took a medical demonstrator job at the University of Western Ontario, teaching students practical clinical skills. In other words, he wasn't really a scientific researcher and didn't have experience running experiments. But that year, he read a research article about people who had clogged pancreas ducts and later developed diabetes. And that gave him an idea for an experiment of his own. He brought it to senior professor John McLeod at the University of Toronto, a leading researcher in sugar metabolism. What if, Bonting asked, we could surgically block the pancreatic ducts in dogs? That would kill the acinar cells and stop them from making digestive juices. He would then be free to study exactly what the islet cells were secreting. McLeod was not impressed, but he said, sure, give it a try, and he assigned one of his students, Charles Best, to help. Just a warning, if you're kind of sensitive to this stuff, the following research gets a little graphic with the dogs. Bonting and Best started their experiment in 1921, and they went something like this. First, get 2 dogs. One of them has its Wirsung duct blocked, so its pancreas can't make digestive juices anymore, but it still has functioning islet cells. The other dog has its pancreas removed. If it survives the operation, it will eventually develop diabetes, which you can measure from its high blood sugar levels. Then, if things weren't already bleak enough, you kill the first dog, remove the pancreas, and grind it up. Inject the resulting extract into dog 2 and measure its blood sugar again. If the extract works, that dog's blood sugar will go down. Now, if it wasn't already obvious, this was a brutal process. Not only were these guys doing really difficult surgery on dogs, they were also working in an unsanitary, unair-conditioned space in the middle of summer. Definitely not a proper operating room. Dogs died from complications and infections, which Bonting felt genuinely bad about. But if they could find a reliable treatment for diabetes, it could be worth it. And they quickly learned that they were on the right track. In dog after diabetic dog, the extract from an islet cell-only pancreas lowered their rising blood sugar. They named this extract iletin, but their work wasn't done. That fall, Best and Bonting brought their results to McLeod, who finally agreed they were onto something. He brought on another member of the team, a biochemist named James Collip, to help purify the islet cell secretion. The team found that calf pancreases can create more of the secretion, and therefore make a stronger treatment. They also studied its effect in rabbits to understand how well their new purification techniques were working. Then, in January 1922, their team was ready to test their new treatment on the first human subject with diabetes, a 14-year-old boy named Leonard Thompson. He was semi-comatose, frequently in the hospital, and weighed just 65 pounds because of his severe diet. The research team's first attempt at treatment didn't quite work, but with stronger injections, improved by Collip, the teen woke up, his health improved, and he soon returned home. Diabetes was no longer a death sentence. But it wouldn't be pancreas research without a fight. In one corner, Bonting wanted to get this islet cell extract to as many patients as possible. He just needed Collip's procedure. In the other corner, Collip said, hang on, you can't do that. This is my extract, my purification procedure. He refused to share. Bonting accused Collip of maintaining bad records on purpose to protect his secret recipe and patent the extract himself. Ding ding, Bonting went to Collip's lab, threw him in a chair by his overcoat, and nearly throttled him. Luckily, Best stepped in and split up the fight, so Wirsung remains the only murder in this episode. With an uneasy truce in place, the team licensed the extract and purification technique to their university, which partnered with the pharmaceutical company Eli Lilly to mass produce the treatment we now know as insulin. In 1923, the Nobel Prize in Medicine was awarded to Bonting and McLeod. Enter the second round of fighting, although as far as we know, it didn't descend into fisticuffs. Bonting wanted to share the prize with Best, who had been alongside him elbow deep in dog pancreases. From his perspective, McLeod not only doubted the work from the get-go, he withheld resources and kept his distance until it seemed successful. But to McLeod's credit, he gave the team legitimacy in the cutthroat world of academic research. He knew how to present these important results to colleagues and stepped in when Bonting froze up at a major scientific conference. Technically, the Nobel Prize can be split among 3 people, so maybe Best could have gotten a slice, but that would still leave out one member of their team. So Bonting split his share of the prize with Best. In return, McLeod split his share with Collip. But the drama wasn't over yet. There was still more academic jockeying as researchers around the world claimed that they provided pieces of the puzzle that led to Best and Bonting's results and the Nobel Prize. And the full story of the team's interpersonal conflicts was kept quiet until the 1970s after all four of them had died. Still, other researchers could take their work and run with it. Over the next few decades, scientists figured out that insulin is just one protein, figured out the building blocks that this protein is made of, and decoded the DNA sequence behind it. Initially, this allowed pharmaceutical companies to better isolate insulin from animal pancreases, and in 1978, they genetically engineered bacteria with that DNA sequence so they'd secrete the human version of the insulin for us. Because it should come as no surprise that human insulin works better for humans than cow insulin does. Major improvements have also been made to the equipment that people use to monitor and manage their diabetes, and insulin itself has been modified into a suite of different medications that work in different ways, like fast-acting or slow-acting versions depending on what a person needs. Millions of lives have been saved thanks to all of these achievements. But on the flip side, this kind of incremental progress also means that all of these drugs and technologies are still protected by patents, making them unaffordable and inaccessible to many who need them. So there's work to do to get this life-saving treatment to people who need it, but we can also remember just how far we've come and the sacrifices that got us here. So pour one out for Johan Viersung and some very, very good dogs. Until we filmed that episode, I didn't know that diabetes research had such a true crime history. Science beefs really can be taken too far. But I guess at least Viersung wasn't thrown down a well and covered in boulders, as Past Me Again is about to tell us. That's what happened to this guy. In central Norway lies the remains of the medieval Sverresborg castle built around 1180 CE. And in the 1930s, excavations of these ruins revealed a corpse at the bottom of a well from within the castle walls. The skeleton revealed that this individual had sustained serious injuries, which, okay, yeah, like obviously he was found in a well which had been filled with boulders after he was thrown in. I mean, what a way to go. And with such a clearly dramatic end, you might be thinking, what a shame this guy's story has been lost to history. I guess we'll never really know what events led to this dramatic demise. Except buckle up, because I'm about to tell you exactly what happened. And it's all thanks to a seemingly unlikely trio: carbon dating, DNA analysis, and Old Norse sagas. This body was initially found during early excavations of the castle ruins in 1938, turning up about 5 meters down a well and covered in large stones. At the time, there wasn't a whole lot that could be done to identify the skeleton, scientifically speaking. It was just some guy in a well, so he came to be known as Wellman. And this first excavation wasn't well documented either, so there wasn't a good record of the fate of these found bones and how they were treated at the time of their discovery. Decades later, when it was decided that Sverresborg Castle should be turned into a tourist destination, dealing with the well skeleton became a priority again. So in 2014, researchers set out to relocate and remove the skeleton from the ruins and try to learn more about the mysterious Wellman. They were only able to recover part of the skeleton, but even with that fragmentary material, these researchers learned a lot from what they found compared to its first excavation. By looking for specific skeletal features, researchers can get some idea of the age and biological sex of the skeleton. For example, in adults, they'll look at skull and pelvic bone morphology to help differentiate between sexes. This process isn't perfect, and skeletons can only give you an idea of sex, to say nothing of the cultural experience of gender, but archaeologists work with what they have. In the case of this particular skeleton, they looked largely at the pelvic region to infer that this was a male between 30 and 40 years of age at his death. At this stage, they also used radiocarbon dating to figure out when this Wellman found himself in the bottom of a well to begin with, a method that wasn't available at the time of the first excavation. Radiocarbon dating can be used to determine when something or someone died, as long as the sample is around 55,000 years old or younger. This method looks at the degradation calculation of a specific radioactive isotope of carbon, carbon-14, which has more neutrons than most carbon on Earth does. These special carbon atoms break down at a specific rate, which makes it a great tool for tracking time. Carbon-14 makes its way into living things via photosynthesis and is cycled around through the food chain. While still alive, all organisms are readily exchanging carbon with the environment, so their carbon-14 concentrations stay relatively consistent. But once something kicks the bucket, no new carbon-14 is taken in, and it's a one-way street of carbon decay. So using radiocarbon dating, we can roughly estimate what year something died. And in the case of Wellman, the first carbon dating estimates put his time of death sometime between 1154 and 1285 CE. That's a pretty wide range, because radiocarbon dating can only get us in the ballpark, not down to specific years. There are a lot of factors that throw off our ability to narrow it down further. For example, diet can cause the remains of organisms to appear younger than they really were. Like, if you eat a lot of fish, your remains might throw future scientists for a loop, because carbon makes its way through marine environments at different rates than terrestrial ones. So the researchers ran the calculation a couple of ways to account for that, and came up with that not quite century and a half range. A more recent study in 2024 made a few other estimates based on a likely diet of around 20% seafood, and presented a very similar range of somewhere between 1153 and 1277 CE. Further excavations took place in 2016, which revealed even more information, including some gruesome details about the skeleton. For one, Wellman's left arm was nowhere to be found, though they did find the fingers that went with that arm. His skull was found, though not attached to his body, and it had sustained some serious blunt force trauma. And to get even more gruesome, these head injuries seem to have occurred before he was thrown into the well, not after. And in the most recent research paper on this skeleton from 2024, another piece of the puzzle was revealed using genetic data of not only Wellman's remains, but that of ancient and modern Norwegians too. The researchers took the DNA data of thousands of modern-day Norwegians and compared their genetics to the Wellmans, as well as the DNA of 23 other medieval Norwegians. These types of studies allow us to learn more about who was where and when, through direct comparison of regionally specific DNA patterns that show up over time. And this particular exploration of Wellman's genetic roots established that the individual came from a population in southern Norway. His DNA analysis also led to the not-so-shocking revelation that he had blue eyes, fair skin, and blonde or light brown hair. I mean, it is Norway after all. Though even this portion of the study wasn't completed without some hiccups, as the DNA sampling itself was a wee bit more complicated than you'd hope for. Given that this particular skeleton had been handled a number of times since its initial discovery in 1938, surface contamination was likely, so they had to sterilize and then grind up a tooth to get a sample without contamination from modern DNA. So after many decades and trials and tribulations, we now know he was a blue-eyed Southern Norwegian from the 12th or 13th century. But what we know about Wellman's story doesn't actually end there. There's more to know about Wellman, because an ancient Norse saga specifically mentions this exact dude. Not by name, but it turns out we know a lot more than just what the science revealed. Now, we're talking about some seriously old sagas, based on events from medieval Norway beginning around 1060 CE. These sagas are part of an incredibly durable storytelling tradition in Iceland, passed down through the centuries and shared with their neighbors. And we're about to see exactly how much detail they can contain. Long story short, in the 12th century, a guy named King Sverre rose to power, and in classic kingly fashion, he became embroiled in a lot of conflict during his reign. King Sverre spent much of his time at war with the representatives of the Roman Catholic Church, called the Baglers. And in 1197, the Baglers carried out a sneak attack on Sverresborg Castle, one of his strongholds. The Baglers not only burnt down all the houses inside the castle grounds, but the saga from this time also tells the tale of Baglers throwing a dead man down a well and then filling it in with a bunch of huge rocks. While we don't know for sure why they did this, it seems likely that they were set on making the castle uninhabitable for King Sverre and his followers going forward. A pretty good strategy for accomplishing this would be to poison the water supply, like with a dead body, for example. Based on the age of the skeleton and the circumstances under which it was found, there's basically no doubt that Wellman is that dude. There's one interesting twist, which is that the Baglers were from the south, while King Sverre and his men were from central Norway. So given Wellman's southern DNA, it's possible that Wellman was not one of King Sverre's men that was killed in the raid, but actually a Bagler, which would mean they poisoned the well with one of their own dead. Unfortunately, this part of the tale remains a mystery. He could have been a Bagler. He could have also been some dude from the south who just happened to be living out his life at King Sverre's fortress when the Baglers stormed the castle. We'll probably never know. While a lot of the specific details of Wellman will always remain a mystery, what we do know is that the archaeological and genetic evidence seem to line up perfectly with the Norse sagas describing this period of time. The discovery of Wellman provides an incredible demonstration of how science and traditional storytelling can be used to reinforce each other in the historical record and strengthen our understanding of human history. This also speaks to the durability of the Scandinavian storytelling tradition, since we found literally the exact guy from these stories written down centuries ago. So thank you, Wellman. I'm sure you would have wanted things to end differently, but you truly became the stuff of legends. Legends that have since been nicely corroborated with the help of modern science. So far, all the crimes we've talked about have been murder or death related, but there's a lot of other criminal activity out there that science can fight using similar DNA analysis. For instance, we can catch scam artists that way. And this might not be the first thing you think of when I say scams, but scientists recently helped nab scammers in the food industry. Here's Niba to explain how.
In 2023, Italian and Spanish law enforcement officials busted a counterfeiting ring and seized tens of thousands of dollars in illegal goods. But it wasn't fine art or currency that the criminals were faking. It was olive oil. Officials seized over 260,000 liters of bogus extra virgin olive oil and arrested 11 suspects for cutting it with olive-derived lamp oil. And this is just one example of food fraud, which is a $40 billion industry that generally involves replacing a food or ingredient on the label with an inferior one. You might think you're enjoying a delicacy like, say, bluefin tuna, when in reality you're eating a cheaper fish that's been dyed with beet juice. So here are some of the world's most counterfeited foods and how science can detect the frauds and keep them off the shelves. Olive oil fakery is a pretty common practice, and old, too. According to archaeological evidence, even some ancient Romans dabbled in some olive oil forgery to turn a quick dollar, or a sestertius. That's a joke for all of you ancient Roman currency lovers. The cardinal rule of food forgery is the product has to taste, feel, and smell enough like the real deal to fool consumers. So there's a process that goes into making counterfeit olive oil taste like it's hot off the olive press on a sunny Mediterranean hillside. With olive oil, it usually involves slapping an extra virgin sticker on a bottle of inferior oil, or cutting real olive oil with other types of oil and altering its color with chlorophyll or beta-carotene. But not all olive oil heists are busted by a multinational sting operation. Some use science to separate the real oil from the fake. Although the olive oil police doesn't yet have an industry standard for detecting fraudulent oil, a 2019 study compared a variety of different methods and found DNA analysis is one of the most efficient methods of detecting adulterated oil. DNA-based techniques for sleuthing out olive oil fakes involve extracting residual genetic material from the oil and looking for unique molecular markers, or specific DNA sequences, found there. This method is so specific, it can reliably tell us if the oil is cut with a different type of vegetable oil, and even how many and which varieties of olive that oil was made from. Moving on from oil to something that you might want to cook in it, fish. There are a lot of fish in the sea, and some of them are mislabeled at your local meat counter. Fraudulent substitutions in the seafood market usually involve passing a cheaper fish off as another, more expensive fish. This can be a huge problem for people with food allergies, or even those of us trying to watch our mercury intake. For instance, according to one Oceana study, as much as 59% of the tuna in the store is mislabeled. It's usually swapped out with a cheaper fish, like escalar. Scallops are another frequently faked seafood. The show Inside Edition hired Applied Food Technologies, a company that specializes in seafood authenticity testing. Applied Food Technologies used an FDA-validated technique called DNA barcoding to see what several NYC restaurants were actually serving in place of the scallops the restaurant said they were. DNA barcoding is used when a scientist is faced with genetic material of completely mysterious origins. A short, specific fragment of DNA is taken from the sample and compared against a vast taxonomic library of genetic barcodes. Turns out some of them weren't scallops at all, and were either a different type of seafood or possibly made made from a slurry of homogenized fish paste. And then there's the really pricey stuff, like caviar. It's a moneymaker for food fraudsters because it's both expensive and hard to come by. Demand for caviar, or eggs harvested directly from a sturgeon's ovaries, has outpaced the farmed fish populations, which means there's a growing problem of shady caviar on the market. And sure, this problem sounds bougie, but it can have serious conservation implications. Because in most countries, caviar is only legal if harvested from sturgeon raised on farms. So one way these caviar traffickers can try to make more money is by illegally poaching wild sturgeon. This particular fraud isn't limited to sturgeon either. Their close relatives, the paddlefish, are also sometimes the victims of this type of poaching, since paddlefish eggs look and apparently taste pretty similar to caviar. One giant 2013 Missouri bust by the U.S. Fish and Wildlife Service and the Missouri Department of Conservation apprehended 112 paddlefish poachers, 13 of whom were charged with the federal crime of illegally trafficking in paddlefish. Because paddlefish are a real target for caviar criminals, busts like the one in Missouri only made a little dent in the problem. One study found that around 30% of caviar on the European market was harvested in violation of conservation laws. Fortunately, it turns out that you can use science to detect that too. Researchers have identified isotope signals in fish roe that indicate where the fish was living when its eggs were harvested, meaning that you can tell the difference between wild-caught versus farm-raised eggs. The same study found that 10% of the caviar they tested wasn't even eggs. These faked products contained what the lab suspected to be sturgeon offal, aka organ meat, unidentifiable DNA, and various non-biological products, which is gross and not at all fancy. Now let's move to the sweets. Honey is another often faked food, usually by diluting real honey with high fructose corn syrup. A 2023 report by the EU found that 46% of imported honey showed some signs of adulteration, which indicates just how widespread the issue is. Of course, there are some methods to detect this funny honey. There's DNA barcoding to tell whether there's any non-honey products in your bear-shaped bottle, which can detect the fake stuff at concentrations as low as 1%. Another test is even easier. A reagent is added to a small honey sample, and the tester just waits for the color to change and proteins to coagulate. The accuracy of this one is still being worked out, but this test has the added benefit of being pretty low-tech. And a cheap, easy way to tell if honey is legit sounds pretty sweet to me. Next up is another sweet treat that's high on the list of common food fakes, because this tree juice is basically liquid gold. Of course, we're talking about maple syrup. It's kind of an open secret that a lot of the cheaper stuff on store shelves is just flavored corn syrup, but that's all good and well as long as the ingredients list is honest. But unfortunately, that isn't always the case, and there are some fraudsters who try to get away with lying about it. One major bust happened in 2000 when a Vermont maple syrup distributor was found guilty of adulterating his maple syrup with cane sugar and ordered to pay back over $300,000 of ill-gotten gains. To detect these frauds, researchers use something called phenolics. Phenolics are a type of molecule that plants make, and they're fairly distinctive across groups. By building a profile of the phenolics in real maple products, they hope to come up with a straightforward test to distinguish between real and fake maple, which means fewer people falling for scams. And speaking of something that goes great in a pie, vanilla is another expensive spice that's often faked. But that's not the problem. The trouble is it's often mislabeled. You've probably seen imitation vanilla in your grocery store's baking section. On the label, you'll see it's called vanillin, and it's a super common flavoring agent in all kinds of stuff. It also has applications in metal plating and other industrial settings, which is wild. I bet those job sites smell awesome. Although vanillin is sometimes made from rice, it's often petroleum-based, so that's not great, emissions-wise. But no, that doesn't mean that imitation vanilla is unsafe to eat. Vanillin is held to every standard of food safety and is tried and tested as safe for consumption. Since real vanilla is so pricey, it's nice that we have a cheaper option, unless you're trying to pass imitation vanilla off as the real stuff, which is illegal. A 3-year investigation in France found that as many as 23% of vanilla products were falsely labeled. They said they contained vanilla when they actually contained the synthetic vanillin. Some producers might be swapping the real stuff for the cheap stuff, or cutting their real vanilla extract with the synthetic. But there's a test for that. To check whether a product is vanilla or vanillin, you can just look at the carbon isotopes. See, when it comes to plants, there are 3 different ways that they can do photosynthesis, and each of them results in a different profile of carbon isotopes in the plant's tissues. Real vanilla plants use a photosynthetic process called crassulation acid metabolism, or CAM, and the isotope signature produced by CAM plants is completely different than what you find in any synthetic vanillin. So all we've got to do is stick a sample in an isotope ratio mass spectrometer and bust some vanilla imitators. While food fraud might be a crime most of us don't think much about, scientists are determined to keep it out of our supermarkets. Hopefully, now you can appreciate the work that went into making sure your little bear bottle is full of nothing but the best honey, or that your vanilla cupcakes are made with the real thing. Bon appétit.
Science can uncover details of murder, scams, and even theft. And I'm not talking about just any theft. This is the story of the criminal who stole birds, and how museum curators brought him to justice.
On the evening of July 23, 2009, a man named Edwin Rist began a carefully planned heist. His target was a museum that he'd scoped out over several weeks, but his prize wasn't jewels or art or the Declaration of Independence. It was birds. Dead birds, specifically. He was after preserved tropical birds held in a museum called the Natural History Museum at Tring, a sub-branch of the London Natural History Museum. He managed to steal nearly 300 taxidermied birds that night, and while the collection has enormous scientific value, Rist wanted them for a much stranger reason. Okay, before we can really unpack how bananas this entire situation was, let's start by talking about the museum that got robbed. The Natural History Museum at Tring was founded in 1892 as the private museum collection of Walter Rothschild, the second Baron of the Rothschild estate. It was home to the weird and interesting objects he collected in his spare time, as rich Victorians would often do. When he died, he donated the building and his collection to the Natural History Museum in London, who used the Tring building as a sort of satellite campus of the main museum, largely focused on taxidermy. The public-facing exhibits contain all sorts of animals, from mammals to reptiles, but the behind-the-scenes collection is where this museum's notoriety really comes from. It's one of the most complete and comprehensive collections of taxidermied birds in the world. The Tring is home to more than 1 million avian specimens, including 750,000 taxidermied skins, 300,000 egg clutches, and thousands of skeletons, nests, and fully mounted display birds. They have specimens representing 95% of the known species of birds on Earth. Most of these are kept behind the scenes and will never be put on display. And while that seems a little stingy, there's a perfectly good reason that the museum needs so many birds.
A lot of the research I do is about the evolution of the anatomy, the morphology, the physical bird. And there's just lots of questions you can't ask about bird biology from wild birds. And the museum, natural history museums, and the collections that they have gathered and provide have created an important context for studying that.
That's Richard Pruhm, an ornithologist and evolutionary biologist at Yale University, and head curator of vertebrate zoology at the Peabody Museum of Natural History. We wanted to talk to him about this story, and not just because he's a bird guy, but we'll get to that. We also wanted to know what goes into keeping a museum collection, because there's a lot going on behind the scenes in a museum. And a big part of that work is making sure that researchers have really good records to go with every object in the collection.
We are eager to make sure that the specimens themselves are preserved, but without the data associated with them, they become just sort of curiosities. And what we really need to do is preserve as well the data of the original place in the world where the bird was from, the date, and all the other information that comes with that specimen. In most bird skins, that's a little paper tag that's tied onto that particular specimen. And then in our case, and most collections now, the data from the labels is computerized and a large database that's searchable, so we can find all of our birds that were collected on a particular date, or in a particular county or nation, or of a particular family or genus, all sorts of ways to search the data. And that becomes a big part of our mission.
Without that data, the birds aren't nearly as valuable to researchers. Like, you can't study bird variation across locations if you don't know where any of your birds came from. But this collection isn't just important for what it means to modern scientists. There are incredibly important historical objects in these shelves too. Some were collected by famed and in some cases controversial naturalists like Alfred Russel Wallace, James Cook, and even Charles Darwin.
We have specimens from all of these eras and personalities, and of course, many of them contributed overwhelming important discoveries to science itself. And many figures that we know well, Charles Darwin and Alfred Russel Wallace, and Bates and companies that began their scientific careers through collecting of biodiversity in far-flung continents. This is both a fascinating piece of scientific history and part of our culture and our cultural legacy. In many cases, this was a exploitative relationship with the different countries that they worked in, but in all cases, it was the primary mission was trying to create a permanent record of biodiversity.
So these collections are important resources for researchers, and they're also valuable historical objects. There were calls to move the collection to London going as far back as 1969, but whether due to cost or logistics, they remained in Hertfordshire. And in an ironic twist, a curator at this same museum had published a report on the dangers to collections like his own, citing theft as a concern. 4 years later, he'd be proven right. Edwin Rist was an American student at the Royal Academy of Music in London, studying the flute. But music was just one of his passions, and his other had to do with rare birds. That's what led him to the Tring on the night of June 23, 2009, carrying wire clippers, a diamond-tipped glass cutter, and a suitcase. Somehow, the guard on duty didn't notice the alarm that Rist activated when he shattered the museum's window, nor did he see Rist clamber in the window on the CCTV cameras covering the museum's exterior. And the cases holding these precious birds weren't locked. So Rist was able to fill his bag with his bounty and escape the way he came in. Bafflingly, even though the broken glass was discovered and the collection inspected the next day, the museum staff didn't realize anything had been taken. They checked only their most conventionally valuable items, and when they saw that all were present, they called it there. It was a full month later when a curator was showing a visiting researcher the collection that the empty drawers were finally discovered, and there were a lot of them. In total, Rist stole 299 birds belonging to 16 different species and subspecies. And he didn't just let them all sit around. Over several months, he meticulously sold this trove in small pieces, in some cases literally cutting them apart or plucking individual feathers off the skins to be sold to his adoring customers. So what did all those people want with the birds? Rist's customers were hobbyists in a niche art practice of Victorian fly tying, where feathers from specific birds were used to make lures for salmon fishing. The lures themselves are intricate and beautiful, and Edwin himself was a renowned lure tyer, often appearing at conventions and expos to practice the art in front of a crowd. The funny thing is, most people who make them now don't even use them for fishing, and the salmon don't seem any more fond of these lures than standard feathers. The community uses the same recipes that were written down in the Victorian days, which was a time where taxidermied birds were all the rage. Women wore them on their hats, and their feathers were used as decorations, and yes, even for fishing lures. Today, some of these birds are endangered or even extinct in the wild, and way more are internationally protected, meaning that their feathers are hard to come by, since getting them from currently living birds is a no-no. So anyone who had a trove of these feathers could make a fortune if they knew who to sell them to, which Rist very much did. And here is where Richard Prume re-enters the story. Prume heard about the theft when the news broke and got personally involved right away.
Anyway, I became very interested when I found out that many of the specimens were birds that I had particular research interest in. Having worked on the physics and anatomy of avian structural colors, optical colors made by feathers. I've worked on a lot of really beautiful birds with lots of interest to the public, and including cotinga, vividly blue, and various birds of paradise, all sorts of iridescent birds, etc. And then I don't remember exactly the details, but it soon became clear that all of these specimens that had been stolen, or most of them, were of particular interest to a very specific community of fly fishermen, or people associate with fly fishing in the preparation of lures or flies for trout and salmon fishing.
So he did what any scientist would do. He went to a local fly fishing conference looking for the stolen birds. He even managed to track down one man who'd sold a skin that matched a species that had been stolen in the Tring heist. While the bird was already gone by the time he got there, he's confident it was one of the missing birds from the Tring. With hundreds of other birds in his possession, Rist was poised to make a fortune selling them. His ill-gained treasure included cotingas, flame bowerbirds, resplendent quetzals, and several types of birds of paradise, many of which were so rare in the fly tying world that a single feather could be worth thousands. Rist sold these feathers in small amounts, often pretending to have found a single skin at a yard sale, or claiming that he was selling the birds on behalf of a private collector who wished to remain anonymous. Over a span of 13 months, he continued to post more and more feathers for sale on his favorite message boards, while also offering full skins to individual collectors. He also sold items on eBay under the username FlutePlayer1988. Thanks to leads from Prume and others involving fly tying, including a man identified only by his nickname Irish, British authorities were eventually able to uncover the identity of the online user who had sold so many museum-quality birds. And Rist was arrested on November 12, 2010, just one day after his final lot of feathers was posted online for sale. His remaining birds were confiscated. He'd plucked many of them and sold the feathers, and he also removed the identifying labels from the birds he hadn't yet destroyed, meaning that of the 299 he stole, only 102 still had research value. Many of these birds were irreplaceable, both as scientific objects and as historic ones. And now, instead of furthering our understanding of ornithology, many of the specimens sit in private collections of random people, taken apart piece by piece and twisted into salmon fly fishing lures that will never be used. The same ornamentation that these birds evolved over millennia to attract mates and show off has captivated humans for just as long as we've known they were there. From the Victorian and Edwardian fashion trends, collectors and their curio cabinets, and now these fly tyers, there's a long legacy of humans being just as enamored with bird feathers as the mates they evolved to attract.
Birds are beautiful because they're beautiful to themselves. They are aesthetic agents in their own ornamental and social sexual evolution. And as a result of the kind of choices they make, we have a complicated history over millions of years of the elaboration of an aspect of the plumage that functions particularly not just in the material world to protect from predators or to fly, but in the subjective experiences of other birds. That is, they function in the minds of other birds. And as a result, they are amazing to study scientifically. But these same features that make them amazing as scientific examples of non-human beauty make them attractive as art forms, as materials for derivative art forms by, human cultures forever.
It's sad that these feathers, which exist to spread their species, are the very thing that makes them so tempting for humans to exploit. Ultimately, Edwin Rist's love for fishing lures made from rare birds left him on the hook, and the only thing that he caught was himself.
Birds aren't the only weird thing criminals are stealing. There's also rocks. Yes, rocks are free, right outside your home, but there are some very expensive rocks. Some of them are expensive because of the hard-to-reach location they came from, and it doesn't get much harder to reach than the moon. So here's what happened when a ragtag team tried to steal the moon.
On July 20th, 2002, about 33 years after Neil Armstrong took his first steps on the moon, astronaut hopeful Thad Roberts took his first steps into an Italian restaurant in Orlando, Florida. And while that sounds less impressive, this NASA intern was about to make history in his own way by completing the biggest heist that the space agency had ever seen. By the way, you like the vibe in here? It's very good. He already had the goods. All he needed to do was complete the sale. Inside that restaurant, Roberts and 2 accomplices met the relatives of a Belgian mineral collector who had agreed to pay $100,000 for roughly 100 grams of moon rocks Roberts had stolen from Johnson Space Center in Houston, Texas. The group talked, agreed to terms, then headed to the hotel where the thieves had stored the loot. But as soon as they entered the parking lot, FBI agents swarmed around them. Roberts and his crew weren't sure yet what had gone wrong, but they were in a lot of trouble. This story is about more than the infamous Roberts heist, though. Over the years, hundreds of moon rocks from the Apollo missions have vanished. Some of them due to negligence, others due to political assassinations, others just plain theft. And around the same time Roberts was scheming to steal lunar samples from the Johnson Space Center, another man there was devoting his life to getting them back. NASA Special Agent Joseph Goodhines was investigating the sale of fake moon rocks when he discovered a thriving black market for the real thing. His career tracking down those rocks would uncover stolen and misplaced pieces of the moon around the world. This is the story of an unlikely group of villains and heroes who, for their own reasons, became obsessed with a few gray pebbles. And as it turns out, those pebbles have a lot to teach us, not just about the moon, but about ourselves. Luna, Celine, Aunt Debbie, whatever you call it, the moon has been our planet's constant companion for about 4.5 billion years. And throughout history, we've pondered what it was and how it came to be. But it wasn't until 1610, when Galileo Galilei used one of the first telescopes, that we could start to answer those questions. Galileo's sketches revealed a barren, dry, and airless world covered in mountains and craters. There were no oceans or living inhabitants, at least none that left a mark on the surface. But while telescopes helped reveal what the moon was not, they didn't help much with figuring out what it was.
We had a very poor understanding of what the moon was made of. Had almost no information about it.
That's Professor Sarah Russell, the leader of the Planetary Materials Group at the Natural History Museum in London.
One of the great mysteries was how the moon got there, and there were lots of theories. There was a theory that it could have separated away from the Earth just by them spinning around. It could have been a captured asteroid. But no one really knew.
To decide between those theories and answer other questions about the moon, scientists needed to learn about its composition, but there was only so much they could glean from more than 360,000 kilometers away. The Apollo missions changed all of that. I mean, yes, one of the reasons 12 NASA astronauts bounced around on the moon was to stick it to the Soviet Union, but from 1969 to 1972, Apollo astronauts also completed a suite of scientific objectives, including collecting rock samples from the lunar surface. And when they came back to Earth, so did those samples, roughly 2,200 of them, weighing 382 kilograms in total. That's about 1/5 of a Kia Sorento. No, we're not going to do that this episode.
That's like a room full of rocks. It's a lot of material. So as well as the kind of big rocks that were brought back, there's also a lot of what's called regolith, which is the fine-grained material on the surface of the moon. There's some rock cores as well. It's a proper geology collection that samples the whole diversity of the places where the astronauts visited.
It turns out the moon's geology, at least the bits that Apollo astronauts visited, is a lot less complex than Earth's.
There's what's called the Highland Rock, and when you look up to the moon on a clear night, that's the white stuff that covers most of the moon, and that's made of a rock called anorthosite. And we think this is the oldest rock on the moon. And then the dark splodges that you can see on the moon, that's a different kind of rock called basalt. And these formed later when there were big impacts into the surface of the moon that triggered remelting and resurfacing of those areas. But then a lot of the lunar rocks have had quite a complicated history from being affected by being impacted all the time. So a lot of the rocks are mixtures of different sort of rocks that have been jumbled together.
Samples of the moon might not make for the most attractive rock collection, but they are critical for scientific research. Remote data from telescopes and orbiting probes gives us the general idea, but each rock sample offers an opportunity to study the lunar surface on a fine scale and paint a much more precise picture of the moon's composition, geologic processes, and history. As a result, NASA treats all of its moon rocks with the utmost reverence. Around 3/4 of all the Apollo samples are stored at NASA's Johnson Space Center. Most of the rest are kept at a facility in White Sands, New Mexico, but at the JSC, the rocks are kept in what's known as the Lunar Sample Laboratory facility inside Building 31N. This essentially windowless room was built to withstand most major weapons, and because it's in Houston, it's also watertight and hurricane-proof. Inside the laboratory, the rocks are surrounded by inert nitrogen gas and are kept inside sealed glove cabinets so that they can be handled without the Earth's atmosphere contaminating them. Anything or anyone that wants to enter has to be thoroughly cleaned first. All of this is kept behind a strict security system that requires 2 people to open the door, similar to the safeguards behind nuclear missile launches. As such, the Lunar Sample Laboratory at JSC is considered as secure as any Federal Reserve Bank or Fort Knox. So if you're a scientist who wants to get your hand on a moon rock, it's a whole process.
One of the glorious things about the Johnson Space Center curation facility is that they do allow and invite researchers all around the world to apply for the materials to use for their research. You have to write a little proposal to say what you're going to do and how much you need and what the effect will be and what the outcomes of your project will be. But then they consider your request, and as a result, there are pieces of Apollo rocks that are in labs across the world.
Of course, NASA isn't about to hand out samples to anybody who asks for them. Now, if you are a scientist lucky enough to get a lunar rock to work on, you have to take as much care as NASA itself, including locking it up in your own vault for safekeeping. And after you've finished with your experiments, NASA wants their samples back.
You absolutely do not get to keep it at the end. At the end of your study, you wrap it up very carefully and you send it back to the curation center. Yeah, there's no souvenirs.
But despite all of the security and protocols, the allure of owning a moon rock, or making money by selling them, is occasionally, apparently, just too much for some to resist. Thad Roberts was a model student right up until he wasn't. Born into a Mormon family in Utah, he was disowned by his parents and the church as a young man. He married his high school sweetheart, Katie, and was determined to make a life for himself. At 23, he enrolled at the University of Utah to study geology, physics, and geophysics, and while he was there, he ran the university's astronomical society and volunteered at Utah's Museum of Natural History. He raised thousands of dollars in a charity bike ride and had his private pilot's license and scuba qualifications. With such an impressive resume, it was little wonder that in 2000 he was accepted into NASA's prestigious cooperative education program. This initiative gave interns 3 so-called tours at Johnson Space Center between continuing their studies and gave them exposure to some of the work that NASA scientists do, as well as opportunities for future employment. Many applicants, including Roberts, aspired to be astronauts and saw the program as a way to get a foot in the door. But that made it highly competitive. The acceptance rate at that time was only around 6%. By all accounts, Roberts thrived during his co-op experience. During his first 2 tours at JSC, he flexed his geological muscles, learning how to prepare meteorites and terrestrial rocks for later study. And this work took place in Building 31N, home to the Lunar Sample Laboratory, and scientists like Professor Everett Gibson, who had been studying moon rocks and meteorites for the last 30 years. The 2 men didn't work together directly, but they did have a few encounters. Roberts even introduced Gibson to his wife when she visited the campus. At that meeting, Gibson gifted Katie a small piece of meteorite, but Roberts came away with something more valuable: an idea. Gibson stored the lunar samples he worked on not in the high-security Lunar Sample Laboratory, but in a 5-drawer safe inside his office. And that meant the professor's moon rocks had been out of the inert nitrogen atmosphere of the lab. They were nowhere near as valuable as they once were.
There are some projects that you just can't do except on a pristine sample. So one example might be looking at the noble gas abundances. So it could be that any sample that's experienced the Earth's atmosphere will be contaminated for those sorts of analyses.
But Roberts wondered if these contaminated moon rocks might still be valuable to somebody outside NASA. Gibson's safe was locked and his office was locked, but compared to getting past the Lunar Sample Laboratory security, it was a walk in the park. Plus, When the professor had opened his safe to retrieve Katie's meteorite, Roberts saw him reference a card stuck to the safe and assumed that that must have been the code. That would be one obstacle already taken care of. If Roberts could somehow get his hands on those scientifically worthless samples, he could cash in on rocks that he thought wouldn't even really be missed. It was, he convinced himself, a victimless crime. Now maybe all this sounds like it's a little out of character for a model student and aspiring astronaut, but Roberts' resume didn't paint the whole picture. In fact, this wasn't the first theft he had attempted. While he was volunteering for Utah's Natural History Museum, several impressive fossils found their way to his house. He claimed that they had been given to him, but the truth was he had simply helped himself. Back in Building 31N, Roberts began conceiving a plan to steal the moon rocks from Gibson's safe. He knew he wouldn't be able to get them on his own, so in 2002, he put together a team of like-minded troublemakers. His first recruit was Gordon McWhorter, a student he met at the university's Utah Astronomical Club. Like Roberts, McWhorter was estranged from his family. He'd already had a run-in with the law, and by his own admission, was a pretty heavy user of recreational drugs. As a result, he knew his way around some of the shadier parts of society, including the early 2000s internet, which I don't remember as very shady. Mostly it was like All Your Base Are Belong to Us and X-Files fan forums. After becoming friends, Roberts floated the idea of perhaps maybe selling some moon rocks. Eventually, McWhorter agreed and helped him look for a buyer. Because it's not like you could post an ad on Facebook Marketplace. Facebook didn't exist in 2002. We were still a year out from MySpace at that point. So, on March 9th, McWhorter posted on a few message boards based outside the US, advertising priceless moon rocks now available. He followed this up with emails to various European mineral collectors under the alias Orb Robinson, which I love. Turns out this is based on his favorite musician, Roy Orbison, who, it turns out, is also somebody who studied geology. I didn't know that the Big O studied geology in college, but there you have it. Eventually, McWhorter got a Belgian collector to bite, and then handed the email address over to Roberts. His part in the heist was basically complete. Next on Roberts' team was Tiffany Fowler, a 22-year-old co-op at Johnson Space Center. She had just graduated with a degree in biology at Texas Lutheran University and was working in JSC's tissue culture lab. Although Roberts was married, he fell hard for Fowler when they met. A passionate affair began, and less than a month before he planned to steal the moon rocks, he brought his new love in on this scheme. Rounding out the roster was 19-year-old Shay Sauer, an engineering intern and straight-A student with 2 years of college credits at Lamar University. We don't actually know much about how or why she ended up getting involved, but both Fowler and Sauer would ultimately join Roberts as his boots on the ground, with the promise of a cut of any sale he made. By July, the crew was set to do the unthinkable: rob NASA. But Roberts had good reason to believe he could make a fortune selling a bunch of gray stones. There was something of a precedent, which lawyer and one-time special agent Joseph Guttheins knew all too well. Guttheins started out in the military. Born the son of Marines, he served in the Army as an aviator and intelligence officer. After he left, he became a special agent for the Federal Aviation Administration and then the Department of Transportation. Eventually, he caught the attention of NASA.
They liked what I was doing. They brought me into the agency, made me a senior special agent, and that's where I really started to have fun. Any law enforcement agent and any pilot is naturally gravitated towards NASA. It's like the ultimate, right? If you're a law enforcement agent, there's no other place you want to be a law enforcement officer than NASA.
In 1990, Guttheins was recruited into NASA's Office of the Inspector General, or OIG. It's on the same level as the FBI and the Secret Service, and is dedicated to rooting out crime, fraud, and waste. And while he was enrolled in law school at night, he found himself stationed at Johnson Space Center.
For most of the time I was at Johnson Space Center, I worked in a high security facility. It had like 2-foot brick walls all around it. It was partially buried under the ground. There were safe doors that you would have to go through to get from one place to the next, or cipher locks that would open up doors. I was running a 25-man and woman task force investigation that resulted in the largest count indictment and conviction in NASA history.
Throughout his 10-year career as a NASA special agent, Guttheins worked on a variety of cases, many of which demonstrated that despite its bunker-like buildings, cipher locks, and two-party vault doors, NASA security really wasn't all it was cracked up to be. He investigated problems and fraud concerning the space shuttles, he investigated the Mir space station project, through which some Russians were billing NASA for their million-dollar homes, and he investigated individuals who made it much farther into NASA's facilities than they should have.
In June of 1998, I had just arrested Jerry Allen Whitridge, that some called the great astronaut impersonator. He got into mission control during the space mission, got the schematics to the shuttle propulsion system, VIP tours to Navy bases, etc. But he claimed to be a Congressional Medal of Honor winner, Top Gun trophy winner, astronaut S1, there's no such thing, and CIA assassin. And based on that resume, he got into mission control. And so I arrested the guy.
While doing this work, Guttheins became aware of a minor but pernicious crime that was becoming more and more common: the selling of bogus moon rocks. This con actually started straight after Apollo 11, with door-to-door salesmen offering so-called lunar rocks to people who weren't aware of the security and legality around them. Most of these marks were just everyday folks caught up in the excitement of the Apollo program, so they wouldn't know the difference. And if they ever had doubts, getting actual confirmation would mean revealing that you now had something you legally weren't allowed to have. So these people often ended up paying a lot of money for a plain old Earth rock and a clever lie. Seeing the average Joe getting conned while also undermining the work NASA was doing really got under Guttheins' skin. So in 1998, while waiting for that astronaut impersonator to show up in court, he decided to do something about it.
And I decided, well, you know what? I'm not going to wait for these con artists to come to our attention. I'm going to go after the con artists with a sting operation.
For Operation Lunar Eclipse, as it became known, Guttheins basically set up a fake company called John's Estate Sales. He assumed the alias Tony Coriasso and pretended to be working for a wealthy client. On behalf of this fake company, Guttheins put a quarter-page ad in USA Today. It featured a picture of an astronaut jumping on the moon and a headline, "Moon Rocks Wanted," and a phone number for potential sellers to call.
About 10, 14, 12 days later, we get a call on my dedicated hello line. And I go over, listen to the recording. A guy by the name of Alan Rosen says, "I got a moon rock." Great. I'm expecting it to be a con artist. Call the guy back up. "Hello, this is Tony Coriasso. I'm with John's Estate Sales. So you have a moon rock?" He said, "Absolutely, but don't believe any of the other people trying to sell you a moon rock, because they're bogus. I got the real thing."
Guttheins, of course, was used to this kind of claim. Every con man wants to convince you that theirs is the only offer worth considering. But when he saw a picture of the rock Rosen was offering, he realized he might actually be dealing with the real thing, because it looked an awful lot like a Goodwill rock. See, not every rock that the Apollo astronauts brought back wound up in NASA storage or in scientists' labs. In fact, hundreds of tiny moon rocks were intentionally distributed all over the world.
The Nixon administration decided to give 135 nations of the world, the members of the United Nations, friends and foes alike, a moon rock from the Apollo 11 mission and a moon rock from the Apollo 17 moon rock mission.
They did the same for the 50 US states. So in total, 370 Goodwill rocks were given out between 1969 and 1973. Each consisted of a few pieces of dust or a pea-sized piece of moon rock encased in a ball of a resin called lucite. The ball was then mounted on a wooden plaque with the recipient's country or state flag. These Goodwill rocks were gifted to the people of those nations and states and were intended to be displayed as a symbol of human achievement. But now, one was being offered to John's Estate Sales.
The name of the recipient country is blocked out, and the center of the flag is blocked out. I'm going like, oh, that's real clever. I got the rest of the flag, I just am missing the center. And the reason why that was clever is that there are 6 countries in Central and South America with exactly the same flag. And lo and behold, the center is the only thing that's different on any of them. And so now I knew there was one of 6 countries that this moon rock could be from, and we started looking into it. And country after country, I ran into the same problem. The recipient nations didn't know, 1, that they even got the moon rocks, or 2, where they were.
He might not have known exactly which Goodwill rock he was dealing with, but Goodhines was pretty sure he'd just found a real missing moon rock in an operation meant to catch fakes. Rosen was asking for $5 million in exchange, apparently based on black market rates, and he wouldn't even show the goods until he'd seen proof of the cash.
And I thought, no problem. Called up NASA. We're not going to put up $5 million for that. Called Department of Justice. No way. NASA OIG calls up CIA. Can't get the $5 million.
So Goodhines turned to an unlikely source, someone he knew had helped people out in the past, billionaire businessman and one-time presidential candidate Ross Perot.
He's like one of the richest guys in the United States. I got through to his secretary. Said, yeah, we need to see if he'll loan some money to us. We're trying to get back a national treasure. And she says, sure, I'll let him know.
And just moments later, Goodhines got a call.
Ring, ring. Pick up the phone. Hello. Hello, Joe. This is Ross Perot. How can I help you? I said, well, Mr. Perot, we need $5 million to get back a moon rock. No problem. And that was it.
Perot might have been able to cough up $5 million like it was spare change, and of course, it would never actually leave his bank account if NASA's sting was successful, but that's an incredibly high asking price for 1 gram of rock. Which begs the question, what is a moon rock actually worth anyway? Many people would argue that their greatest value lies in what they represent.
I remember I was just a small child and I used to get excited about everything. But with the Apollo missions, even the adults were excited. And I remember being astounded that adults could get so excited about something.
At places like the Smithsonian National Air and Space Museum and Space Center Houston, visitors can physically touch a piece of the moon. And for many people, that can be a transformative experience.
I went to an astronaut. A famous astronaut, and I said, hey, look, do you think $5 million is reasonable for 1.142 grams of rock? He said, you know, Joe, I have no clue. But he said, I'll tell you this story. He said, when I was a kid, I always wanted to be a pilot. And he said, I went to a museum and I started coming up to this display with a moon rock. And somewhere between the point that I started to the point that I got to the moon rock, I no longer just wanted to be a pilot. I wanted to be an astronaut.
Apollo lunar samples are essentially the rarest rocks on Earth. We don't have the technology or budget to easily replace them. But in a way, they'll always be irreplaceable. They're relics of a singular time in world history, representing a temporary peace in an otherwise tense and expensive arms race between the US and the USSR.
I can look up in the night sky and I can see where this sample came from, and yet I can hold it in my hand, holding something that somebody selected over 50 years ago, chose, and then made this treacherous journey to the moon and back to bring it for me to look at in my lab. That's a real privilege to be able to do that.
History is important, but lunar rocks do, of course, have value beyond symbolism. It's been more than 50 years since Apollo 17 returned with one last set of moon rocks, and in that time, NASA has received thousands of research requests from hundreds of scientists in more than 15 countries. The agency has distributed around 50,000 samples for use in scientific scientific fields ranging from astronomy to biology, chemistry, engineering, materials science, medicine, and geology. Studying these samples have solved many scientific mysteries about the moon itself, as well as the Earth and the rest of the solar system.
If we have a physical lunar sample, we do all sorts of microscopy on it. So that includes optical microscopy using light, but also using electron microscopy, which means that we can get down to really tiny samples and look at it on a very, very small scale, which gives us a much better idea of how the minerals formed. And then we can also do chemical analyses, which enable us to compare it to the Earth and to other bodies.
The moon doesn't have plate tectonics or any kind of air or water to erode the surface, so pristine Apollo rocks are all at least 3 billion years old. They retain a record of early solar system events that you can't find anywhere else. They've even helped researchers understand a whole other kind of rock in their collections. Basically, until we went up and collected pristine bits of the moon, we didn't know that pieces of it had already crashed into the Earth in the form of meteorites. But probably most significantly, the Apollo samples helped us solve the mystery of how the moon got there in the first place.
They were incredibly dry compared to Earth rocks, so they had lost water and lots of other volatile elements as well. But apart from that, in lots of kind of chemical signatures, they were identical to the Earth. And that means that somehow their genesis was linked to that of the Earth, but they had lost something.
These observations not only discounted the ideas of the moon being captured by Earth's gravity or forming alongside it, but they lent support to another controversial hypothesis from the 1940s. The hypothesis was that not long after the Earth formed, it was hit by another Mars-sized planet. The impact vaporized and liquefied the colliding planet, plus a lot of the Earth's outer layers. Everything mixed together, and eventually, the moon formed from the debris.
So that's why they got similar compositions. But then as the spray that comes out, a lot of it evaporates into space, so that affects its composition.
Ultimately, the Apollo moon rocks helped to establish the entire field of modern planetary science, and their contribution is just as significant today as it was 50 years ago.
Once they're back on Earth forever, and so we can use them, but also our descendants in 200 years' time can use them to answer questions that we haven't thought of using techniques that don't exist at the moment. And so it's the gift that keeps on giving.
NASA has even left some Apollo samples completely untouched for the last half-century, specifically waiting for new questions and new technologies. Through both the science that's already been done and the science to be done in the future, the Apollo lunar samples have proved their worth time and time again. Just ask Sarah Russell.
The Apollo rocks are absolutely, completely irreplaceable, and these samples are absolutely priceless.
But that does not stop some people from trying to put a price on them. Alan Rosen was not the first, and Thad Roberts wouldn't be the last. Anyone can buy a chunk of the moon, and it's perfectly legal so long as it didn't get here with any human help. Lunar meteorites will set you back about $100 or $200 per gram. But all of the Apollo samples officially belong to the United States, or in the case of the Goodwill rocks, to the nations they were given to. It is illegal for any individual to own any Apollo moon rock, but it is legal to sell space dust that has gathered on space artifacts. That's wild. In 1993, the auction house Sotheby's sold 3 specks of lunar dust from the USSR's Luna 16 sample return mission. Approximately 0.2 grams of material set the anonymous private collector back $442,500. Now, if that's outside your budget, you might be interested in paying just under $1,000 for a 3mm strip of tape with lunar dust on it, originally owned by a NASA photographer who got some dust on his fingers when he opened a film canister that Neil Armstrong dropped on the moon. Meanwhile, in 2018, a case of theft, fraud, and mistaken identity meant that an Apollo 11 collection bag ended up in the hands of a lawyer from Illinois named Nancy Lee Carlson. NASA tried to take it back, but Carlson won the case. She ended up selling the bag for $1.8 million and a pinch of lunar dust from inside of it for $500,000. But if you are headed to the black market to get your hands on some illegal stuff, the price is probably going to be even higher. Records of such underhanded dealings are unsurprisingly scarce, but a Nicaraguan Goodwill rock is rumored to have sold along with some other artifacts for $10 million. And space historian Robert Perlman has estimated that a Goodwill rock on its own could fetch up to $1 to $2 million at a public auction. But Alan Rosen, the guy offering a Central American Goodwill rock to John's estate sales, had gotten his for an absolute bargain. In 1995, a colonel sold it to him for $15,000 plus a refrigerated truck. Whichever way you look at them, their symbolism, scientific worth, or raw collector's appeal, moon rocks carry a far higher value than their gray, crusty exteriors would suggest. So Thad Roberts had plenty of reasons to get his hands on Gibson's samples back in 2002. Unlike Alan Rosen, who had a Goodwill rock 3 years before he saw Goodheinz's newspaper ad, Roberts wanted a buyer lined up before he so much as breathed on a stolen moon rock. That buyer turned out to be Axel Emmerman, a member of the Antwerp Mineralogical Club in Belgium. He told Roberts that he was interested but wanted proof of authenticity and to know how much Roberts was asking for. In May, Roberts promised this proof and offered a price as low as $300 per gram. However, he asked Emmerman to commit to buying at least 1 kilogram of the samples. In other words, at least $300,000. But when Emmerman didn't immediately respond, Roberts got nervous, started bombarding him with emails, assuring him of his intentions and pressuring him to commit. Eventually, the Belgian said he was willing to spend $100,000 but couldn't come to the US. Instead, Roberts would have to meet with his American sister-in-law, Lynn, who was also a mineral collector and would be able to authenticate the rocks on Emmerman's behalf. After a lengthy exchange of emails between Roberts and Lynn, the pair agreed to meet on July 20th in Orlando. The evening of Saturday, July 13th, Roberts, Fowler, and Sauer were ready for their historic heist. The 3 NASA interns drove to JSC in a Jeep Cherokee that Roberts had borrowed from a friend under the pretense that he was moving to a new apartment and needed the extra space. This was all going down during Roberts' 3rd tour at NASA, and he no longer worked in Building 31N, so the first hurdle was getting the code to enter the building. That turned out to be easy. All he had to do was lie to a colleague and claim he needed to process some photos in his old lab. Sauer stayed in the car, while Roberts and Fowler headed to Professor Gibson's lab, hitting hurdle number 2, a 5-button cipher lock on the door. That turned out to be an inconvenience, but not a complete deterrent. Roberts knew the code must be a combination of 4 of those 5 buttons without any repeats. So he simply worked his way through as many of the 232 possible combinations as he could until he found the right one. Once they got into Gibson's office, Roberts and Fowler ran into hurdle number 3, the locked safe containing their prize. But here's where their plan went awry. Roberts thought that the card he'd seen Gibson reference had the safe's code written on it, but it was actually Gibson's hint to himself for remembering the code. It was of no use to them, and the combination lock was harder to crack than the one on the door. So the 2 lovers had to go with plan B. They took the whole safe. Lifting it together onto a dolly, they wheeled it back to Sauer and the Jeep. The team loaded it up, drove off the campus without a single blink from security, and took it to a Motel 6 where they used power tools to break in. Say what you want about motels, but you really do get the privacy to do whatever you'd like. Inside the safe, the trio found more than 50 lunar samples, all stored inside vials and boxes in Teflon bags. In total, there were just over 100 grams of the moon in there. There were also around 150 meteorites, including 8 rare and valuable Martian meteorites. That's right, little bits that got blasted off the red planet and came crashing down to Earth. One of them was a piece of ALH 84001, a Martian meteorite that became famous for potentially containing alien microfossils. Roberts, Fowler, and Sauer, along with McWhorter hanging back in Utah, had hit the motherlode. In addition to the physical samples, Gibson's safe was also filled with documents that supported the identity of those samples, as well as their current state. Just the proof Roberts needed to convince his Belgian buyer that his rocks were legit. Over the course of the night, Fowler documented what they found and took photos of their progress. Then, The trio put the lunar samples and meteorites into a fishing tackle box and scattered the mangled safe across several dumpsters. Even with that hiccup involving Gibson's safe, it was a nearly perfect heist. No one had seen them come or go. The theft itself wasn't noticed until the following Monday. Gibson was in Australia at the time and received a call at 4 a.m. to tell him the terrible news. He came straight back to the US, but there was nothing he could do. There were no leads to follow. On July 19th, Roberts and Fowler started their drive from Houston to Orlando. Meanwhile, McWhorter flew in from Utah, keen for some of the excitement and for the money. The three met up at the Sheraton Hotel on the morning of July 20th and took their tackle box full of stolen moon rocks up to the room they'd booked. Then, depending on the sources you read, this bit is where things get a little steamy. Roberts has claimed he put the samples under the sheets of the bed and made love to Fowler on top of them so they could be the first people to have sex on the moon. That's not how it works, and also, it sounds uncomfortable. It's a good story, but later FBI photos showed the room with a perfectly made bed, which casts more than a little doubt on that claim. As the time for the sale approached, they slipped the tackle box under the hotel bed and headed to the Italian restaurant to meet their buyer. 4 years earlier, Alan Rosen had also agreed to sell his moon rock in Florida. Why is it always Florida? He arrived at a Miami bank expecting to meet a representative of John's estate sales. That representative, however, turned out to be an undercover US Customs agent who seized the rock and arrested Rosen. Joseph Goodhines and his team got their man. Once he had the plaque in hand, Goodhines could see that this Goodwill rock belonged to Honduras. But before anyone could celebrate, scientists had to confirm the rocks inside the lucite ball really were from the moon.
I put the moon rock in my pocket for about 24 hours and flew it back to Houston to be tested. And I had my briefcase, was doing a real good job putting it away in case anybody knew that we had the moon rock, but it sat in my pocket the entire time.
Back in Houston, NASA's lunar curator examined the piece.
Sure enough, our geologists could tell not only that it's from the moon, but which mission came from the moon. It was from our last mission there, Apollo 17.
All the Apollo 17 Goodwill rocks, turns out, were cut from a single rock named Sample 70017. Since some of the samples still existed, the lunar curator just needed to compare its chemical fingerprint to that of the seized rock. And they were identical. Despite having a genuine Goodwill rock and its seller in hand, the legal case that followed was long and messy. The crime actually came down more to customs than any kind of theft. Titled United States of America versus one lucite ball containing lunar material, one moon rock, and one 10-inch by 14-inch wooden plaque, the 5-year case examined whether Rosen actually had the right to sell the Honduran moon rock after he had bought it, and whether he'd declared it when he brought it into the country. The problem was, NASA gave over all rights to the Goodwill rocks when it gifted them to their recipient nations, and the agency made no effort to keep track of them afterwards. But they were always meant to be owned by the people, not to be traded for the leader's personal gain. So when the case finally went before a judge in 2003, it was the colonel's acquisition of the rock that was ruled illegal. That gave US Customs the right to seize it and allowed Alan Rosen to get off without being charged. The plaque was returned to Honduras and is now on public display, as originally intended. And Joseph Goodhines earned a NASA Exceptional Service Medal for leading the operation to retrieve it. But he wasn't even working for NASA at the time. A few years earlier, Goodhines had retired from the OIG and started working as a lawyer. By 2002, he was also teaching at the University of Phoenix and Alvin Community College, training the next generation of police detectives.
My mentor said, we encourage our instructors to teach what they know. And you were with NASA, and you're the only guy from NASA OIG, and would love for you to give some sort of your background to the teaching.
But Goodhines didn't just teach. He also recruited his students into his own unofficial task force, because during Operation Lunar Eclipse, he realized just how many Goodwill rocks had disappeared.
When I realized that a lot of these countries have no clue where their moon rocks were, I encouraged my agency to do a broader investigation beyond Operation Lunar Eclipse. We didn't have the resources. We were a very small law enforcement agency. And so all of a sudden now I had graduate students learning to be criminal investigators. And I decided, why not give them a real task? I'm going to send them out there and we'll see how it goes.
Whether or not a student actually found a missing rock, at the end of their project, they'd have to either write a report or publish an editorial in a newspaper.
What I like about the moon rock cases is nobody's going to get hurt going after the moon rocks. And if they find a moon rock, people are going to benefit. Kids are going to see them in museums. I believe what NASA believes. I don't believe private individuals should own moon rocks or dust. I believe they belong to the people. Half my students would start off by going like, are you kidding? We're hunting for a moon rock. And about halfway through, they would be just as involved in it as I am.
While getting a bunch of college students to sniff out missing Apollo souvenirs might seem a bit ridiculous, Guttheins's project was actually a huge success. For one thing, the students were able to track down rocks that had simply been lost or misplaced. California's was found in storage at the San Diego Air and Space Museum, where the curators had forgotten they had it.
North Carolina, there was a moon rock found in a drawer. Nobody knows why it was there.
Canada's rock had been lost since 1978, but it turned up in a storage facility owned by Canada's Natural Science Museum.
My student, Kevin Griffiths, finds out that the Apollo 17 moon rock of Colorado is missing. There's a front page story out, and that day the governor, after 30-some years of having it, says, I've had it on my wall the entire time. And now it sits at the Colorado School of the Mines.
But sometimes the rocks had actually been stolen. In 1973, an arsonist set fire to Alaska's State Transport Museum, which had been charged with displaying the state's Apollo 11 Goodwill rock. After one of Guttheins's students published her report in a local newspaper, unable to find the rock herself, a man came forward to sue Alaska. He claimed that he rescued the rock from the rubble during the cleanup and demanded he either be declared the legal owner of the rock or given $5 million. An FBI investigation revealed, however, that the plaque had gone missing sometime after the fire. The man, who'd been the foster son of the museum's curator at the time, returned the rock to the government, just like Alan Rosen, and he did not get his $5 million. But this was not the only theft Guttheins's students ran into.
I want to find Malta's Apollo 17 moon rock because one of my students woke me up at 3 o'clock in the morning to tell me that it had been stolen from a museum where someone walks in, opens up a case, takes the moon rock off the plaque and walks out.
Guttheins believes that that theft, which happened in 2004, was made by an opportunistic amateur. They only took the lucite ball and not the plaque that would prove its authenticity and its value. But despite offering amnesty and a $10,000 reward for its return, at the time we're filming this episode, there's still no sign of the Maltese rock. Losing a Goodwill rock is one thing, having it stolen is another, but the most dramatic cases might be the ones that feature political unrest. Like in Romania, where a Goodwill rock wound up sold in an estate sale after the country's dictator and his wife were executed. Or in Cyprus, a Mediterranean island with an ongoing conflict between Christian Greeks in the north and Turkish Muslims in the south.
Cyprus allegedly was missing both of their moon rocks, believed destroyed in the fire when they were going through civil unrest in 1973.
But in 2009, when Guttheins's students contacted them, the National Museum had never even heard of a Goodwill rock. It turned out that one had been sent to the island in 1973, but a year later, there was a coup attempt and an invasion. The president was ousted and the presidential palace burned to the ground. There was also violence at the American embassy, in which the ambassador was assassinated, likely before he had a chance to give the rock to Cyprus. Guttheins and his students worked with a Cyprus newspaper reporter to publish a media blitz demanding NASA investigate. Not long after, the agency was contacted by an attorney representing the rock's custodian. He was the son of an American diplomat, claiming his father took possession of the rock when the embassy was evacuated in 1974. In 2010, he handed it over in exchange for immunity from prosecution.
And then it took me another 12 years to get NASA to do the right thing to return it to Cyprus. And they didn't want to return it to Cyprus because of all the political turmoil and the politics and everything else. And they forgot the whole reason why we gave these moon rocks in the first place. We weren't picking winners and losers. We were giving the moon rocks for the people of each country to enjoy. And just because Cyprus had some strife down there was no reason not to give them back their property.
It turns out the threat of prison time is enough to dissuade many people from trying to keep or sell an Apollo moon rock. Just not Thad Roberts. Lynn waited alone at her table for Orb Robinson to arrive, and when he finally did, she recognized him from the clothes he said he'd be wearing. But Orb, aka Roberts, was not the professional type she was expecting. Likely nervous, he talked a lot, boasting about how he'd broken into Building 31N and stolen the safe. At the end of his story, Roberts joked that he hoped she wasn't wearing a wire. But everything seemed to be going well. Lynn's husband, Kurt, soon joined them at the table, as did Fowler and McWhorter. Both sides of the deal judged the other as legitimate, and they agreed to the sale. They drove back to the Sheraton in 2 cars, but before they could even leave the parking lot, the FBI descended. Lynn had, in fact, been wearing a wire. Not only that, she herself worked for the FBI. Back in May, when Axel Emmerman first received Orb's emails, he nearly dismissed them as spam, but something nagged at him. Whatever Orb was doing was a crime. At best, it was fraud, and at worst, it was theft. So the mineral collector contacted the FBI in Tampa, where Orb said he was based. The entire time he was emailing Orb, he was also coordinating with investigators. The FBI was able to analyze Orb's emails and found they weren't coming from anywhere in Tampa or Florida for that matter. Sometimes they originated from the University of Utah, and sometimes from Johnson Space Center. They didn't start asking around NASA though, because if this were an inside job, they could spook the perpetrator. But they did have their eyes on a couple of Utah professors who also worked at JSC. And they eventually teamed up with NASA's investigators once they both realized they were investigating the same case. They still had no idea it was an intern they should be looking for though. It was the FBI who suggested Emmerman schedule a meetup on American soil to lead Orb, whoever he was, into a trap. And to help sell the ruse, they recruited Special Agent Lynn Billings, who had trained as a geologist. Her fake husband, Kurt, whose real name is Lawrence, was also an FBI agent and learned a single line of Flemish to play his role. In the event that Lynn needed to confirm the moon rocks were legitimate, Emmerman told her to look for zap pits. On the moon, tiny particles constantly rain down from space, but without an atmosphere to slow them down, they hit the surface going as fast as 80,000 kilometers per hour. They're basically microscopic meteorites, creating correspondingly tiny impact craters called zap pits. They have a surface of black glass surrounded by a white halo of pulverized rock, and every moon rock is covered in them. Although the pits themselves can be faked, the unique textures within them cannot. Thad's zap pit-covered rocks were found right where he had left them, in the fishing tackle box under the bed in room 905. The trio of criminals who had come to Florida were arrested then and there. 2 days later, Sauer was arrested in Houston. Professor Gibson got all of his moon rocks and meteorites back, and the 4 criminals were charged with conspiracy to steal, transport, and sell government property. But to determine how severe their punishments would be, prosecutors needed to calculate the value of what they had stolen, and instead of going by black market rumors or a few legal sales, the FBI used the cost of the Apollo missions themselves. In 1961, Kennedy announced that the space program would cost every US citizen 50 cents per week. The final total was more than $25 billion. Now, not all of that went towards bringing moon rocks to Earth, of course, so the government's number crunchers only took into account what proportion of each mission was dedicated to sample return. For instance, every gram of material removed from the lunar surface needed 3 extra grams of propellant. Eventually, they arrived at $50,800 per gram at the time, or $203,000 per gram in 2003, and a total of $21 million for the moon rocks that Roberts and company stole. The meteorites added even more to the sticker price. The famous ALH 84001 sample from Mars was valued at $1.8 million all by itself. NASA's cost analyst pegged the total replacement cost for all the samples at $32 million. That's a lot of money for what Roberts claimed was a victimless crime, giving trash lunar samples a new lease on life. But Roberts had just conveniently ignored the fact that while contaminated samples can't be used for everything scientists want to study, that doesn't mean they're completely useless. As we've heard from Professor Russell, experiments are done outside of the Lunar Sample Laboratory's pristine environment all the time. You just have to be very careful and keep track of everything you did to them, so future scientists know what to account for in their research. And honestly, Thad, scientists do research on lunar meteorites, which have gone through the atmosphere and burned up a little bit. Obviously, these things are still valuable. To date, only about 20% of all Apollo rocks have been so degraded that they have no scientific use. However, the indiscriminate handling of these stolen samples created a different type of contamination, a broken chain of custody that had started the moment the astronauts selected the rock on the moon's surface. The 4 students had personally handled the rocks, and there are even reports that one of them ate some. Without knowing which samples had been affected and to what degree, the event basically ended these rocks' scientific careers. But even then, they wouldn't be considered trash. They would still be used for education and outreach. As it turns out, the most damage wasn't done to the rocks themselves. Professor Gibson reported that his stolen safe also contained 30 years worth of handwritten research notes, and while the lunar samples were recovered from the Orlando Sheraton, there was no sign of those notes. Roberts maintained that he never saw them, but Fowler's photographs taken the night they broke into the safe clearly show them lying on the floor of the motel room. When this information came to light during Roberts' trial, the judge weighed it heavily.
I mean, if you don't have notes on what you did, then basically it may as well never have happened. If you don't write about it, then no one will ever know that you did this work. And many of these analyses are destructive analyses. So, unfortunately, you have to destroy bits of the rock to be able to get this data. And once it's gone, and you can never get it back.
In the end, a hearing set the official cost of the theft at $7 million for loss of research and productivity. But to deal out the punishments, the courts considered each student's contributions to the theft and sale. Both Fowler and Sauer got off fairly lightly. They were sentenced to 3 years probation with 6 months house arrest, 150 hours of community service, and $9,000 restitution. McWhorter ended up making life harder for himself. He went against his attorney's advice and pleaded not guilty to the charges, meaning he was the only one to go to trial, and then he jumped bail. At his trial, the witnesses who testified against him included FBI agents, a former Apollo astronaut, NASA's lunar sample curator, and Thad Roberts and Tiffany Fowler. So much for him and Roberts being friends. Ultimately, McWhorter was sentenced to 5 years, 10 months at a federal correctional institution in Colorado. But as you might expect, Roberts bore the brunt of the blame. The prosecutors even threw in a charge for the stolen museum fossils. But because of those missing notebooks, his sentence ended up being nearly double what the sentencing guidelines suggested. In 2003, he was sentenced to 8 years, 4 months in prison, plus 3 years probation and 150 hours of community service. He ended up spending 6 years behind bars.
Even though I'm a defense attorney now, I still have that old law enforcement thing, and you go into hollow ground, you're giving the privilege to do so, and you steal from not only the United States, but the world, because you're greedy or you're whatever. I don't think 8 years was enough. I would have put him in for 20.
It's been 23 years since Thad Roberts and his crew stole a safe full of moon rocks and meteorites, and 27 years since Joseph Gutthein's first embarked on his quest to hunt down the missing Goodwill rocks. And while some of the characters have since steered clear of the limelight, Roberts is not among them. During his years in prison, he taught himself physics. He became especially interested in quantum physics and now publishes and speaks on the subject occasionally. Although we weren't able to find any of his work that has made it through peer review, and our attempts to reach Roberts through his social media and email accounts for this story were not successful. Fowler and Sauer understandably have kept a low profile since their headline-grabbing escapades. Despite their passionate love affair, Fowler never spoke to Roberts again after they were caught. caught. McWhorter claims his prison time saved him from a downward spiral of drug use. He's now an author and a father to several children. Joseph Goodhines eventually retired from teaching and is currently focusing on his work as a defense lawyer at a firm with his sons. But he will never let go of the missing Goodwill rocks.
Right now, there are about 159 of these moon rocks still missing. But we helped recover 78. When I retire, my wife and I are going to go worldwide. We're going to go hunt down every moon rock that's still out there that we're missing.
NASA has acknowledged that hundreds of rocks that it's loaned to researchers have been lost or stolen over the years, but these still make up a tiny fraction of the whole Apollo lunar collection. Meanwhile, the agency did tighten its inventory controls and introduced more stringent security requirements, including that office safes must now be bolted down. But without Goodhines, there's never quite been the same determination to chase the missing Apollo moon rocks. Which is a shame. But the truth is, if we want to keep learning about the moon, we need to move beyond what we gathered during the Apollo missions. Although those samples transformed planetary science, they can't tell us everything we need to know.
The Apollo missions only sampled a very tiny part of the moon. So they only visited the near side of the moon, and they only went to the equator of the moon. So that means we still know very little about the polar regions and also the far side of the moon.
Some of that new sampling has already started. In 2020 and 2024, China launched 2 robotic sample return missions named Chang'e 5 and 6 respectively, and together they've brought back over 3.5 kilograms of lunar material. That's about the weight of 2 2-kilogram hand weights. It's a little less. India is planning to launch their Chandrayaan 4 lander in 2029 and collect 3 kilos near the moon's south pole. And then, of course, there are the much-anticipated private missions, which have the potential to change the landscape of lunar science altogether.
We're sort of on the cusp of a really exciting time because there's so much interest in returning to the moon. And, for most of my professional life, lunar science was sort of bit in the doldrums, but now there's real interest again in having human beings going back to the moon.
The Apollo moon rocks were special for decades because they were among the only ones we had. But what will always make them valuable is the fact that they represent a unique period of history when we first reached for the stars, a time when humanity chose exploration over annihilation. For some, like the custodians of the lost Goodwill rocks, that might not mean much. But for others, like Joseph Goodhines, and maybe even in his own way Thad Roberts, it means an awful lot.
I gotta tell you, walking around with a moon rock for 24 hours in my pocket, I'm going like, yeah, that's connection to something bigger than myself, bigger than any of us.
Sometimes true crime stories from history have even more twists and turns than the crime dramas on TV. Fortunately, science is there to solve them. Thanks for riding along with us in this SciShow compilation. And remember, kids, crime doesn't pay.